All right, for the sim today, there are two parts. Part one, we're really looking at how long it takes for energy to enter and exit the atmosphere when there's no gas in the atmosphere. And then part two, we're going to focus on what happens when we actually interact with carbon dioxide or methane. To access the sim, you're going to go into Google Classroom. Up at the top, you'll see it's posted March 7th, but we moved it up to the top. You'll log into Amplify, and that will enter you into our simulation. Once you're in the sim, you want to make sure that you familiarize yourself with where your time is located, with where the gases are located, carbon dioxide, methane, sulfur dioxide, nitrogen dioxide, and also where your play and pause and speed are, because you're going to want to adjust that to make life easier for you. The directions say to start by setting all of your gases to 0. So to do that, you'll just drag all 4 of the bars all the way over to 0. And so you shouldn't see any little specks in your sky. It says choose one energy arrow that's just entered Earth's atmosphere line. Earth's atmosphere line is this dotted line. So right now there are really none. I'm going to change my speed to slow it down a little bit. And I'm going to hit play. And I see one coming. And the directions say once you find that, press on the arrow, and all the other arrows on the screen are going to kind of fade. We want to track the time it takes for this arrow to come in, go to Earth, and go back out of our atmosphere. Notice, though, I'm already at 1 second. So once I get my total time, I'm going to want to delete that second or subtract that second. So let's take a look. At this point, if you do want to speed it up, you can. Right now, the arrow is kind of bouncing around down in the ocean. It's being absorbed, and now our energy is coming back out, and pause. Once it exits the atmosphere, we're going to take a look at the time, noticing that it took 14 seconds. However, remember, we started at 1 second. So in my data table, I'm going to type 13 seconds. I'm going to do this again, a second time, and a third time. It does say if the energy arrow leaves the side of the screen before it reaches the top or before it reaches the Earth, make sure you choose a new one. It might take you a few tries. After you have all 3 of your times, you're going to calculate your average. Remember, to get the average of 3 numbers, you'll add up your 3 times to get a total, and then you'll divide that total by 3 to get the average. That's part 1. Now looking at part 2, we're going to do a very similar thing, only you're going to focus on carbon dioxide or methane. In your packet, make sure you circle which one you're choosing to do, carbon dioxide or methane. For each interaction, you will only focus on one gas. You will say in words what you see your energy arrow doing. You'll draw what it actually does, and then you'll list the time as well. So when we go back to our sim, we're going to go ahead and we're going to click off of that arrow so we see them all again. If you wish to reset completely, you may do so. The directions read, set your gas to a maximum and everything else to 0, and then make sure you press on that I icon. So I'm going to do carbon dioxide. I max it out, and I set everything else to 0. And then I click on the eyeball. When I click on the eyeball, all these carbon dioxide diamonds show up. Now, I know that I need to watch an arrow that's entering the atmosphere, hits the Earth. Once it's on its way back to the outside of the atmosphere, it needs to crash into a gas. If it does not crash into a gas, start over, pick a new one. So let's go ahead and watch this arrow. Again, it needs to enter, then it must hit Earth. If it hits a gas first, it doesn't count, start over. Hit Earth, then as it's coming back away from Earth, it needs to crash into one of my gases, and then it needs to exit. All the while, we're watching that time. So let's take a look. So this gas comes in, it hits the Earth, it's bouncing around a little bit. When it exits and is coming back off of the Earth, we're going to see if it crashes, and it does not. So we're going to click off of that one. We're going to pick a new one. I'm starting at 15 seconds, though, so pay attention to that. So I'm going to hit play. It comes in. It hits the Earth. It's bouncing around a little bit. Again, if you want to slow it down, you can. I have it at regular speed. Now, it needs to crash. See how it crashed there? It's going back into our earth. And now it's going to crash again and then exit. So I started at 15 seconds and now I'm at 35, which means it took 20 seconds to do this. This is what you're going to do on your page now. I'm going to describe what I observe. I see that my arrow came in. It was absorbed in the ocean. When it came out, it hit a gas and was absorbed. It went back to the ocean. When it was going back out into outer space, it crashed into another gas molecule, carbon dioxide. It absorbed and then it exited. So I would list that in words. In this picture, you're going to draw this. You're going to draw this line going up, down, zigzagging. You're just going to do a sketch of it. And then your time, I would say 20 seconds. Okay. Now, after you've completed one, just click off of that arrow. You need to do the same thing 2 more times. Find an arrow that's just entered, hit play. It must hit Earth, then a gas, and then it must exit at some point. Take note of your time. You're going to do this 3 times, always for the same gas. Never switch your gas. Once you're completed with that, you're going to fill in this box with your answer that you got from part 1. What was the average time with no gases? Then you'll fill in whichever box you completed. So if you did carbon dioxide, fill that box in. Don't fill in methane. If you did methane, fill that box in. Don't fill carbon dioxide in. And then we just have 3 questions. What do you notice about the average time when you have a gas versus no gas? So look at this number and then this number, and what do you notice? Second one says, as we're watching this energy, what do you notice happening in the background still? What is still happening? And then finally, if we have energy being absorbed and held in our atmosphere, what do you think is happening to the total energy in our system? Do you think that total energy is increasing? Do you think the total energy is decreasing? Or do you think the total energy is staying the same?